Hello everyone. The title of this video is Writing Rational Functions. So each example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org. I'm in their Algebra and Trigonometry text, section 5.6, called Rational Functions, and I'm under the heading Writing Rational Functions. Alright, so each example is either going to be an example from the reading or one of the try it problems from the reading, or one of the exercises at the end of the text, at the end of the section, related to this particular objective, of writing rational functions. Okay, so what we're going to be doing is we're going to be either given a graph of a rational function or some information about a rational function and asked to write a function that would match all that information. So everything will start off, will look like this basically at the end. We'll have some scaling factor called a times, and then in the numerator we have x minus x1 to some power, x minus x2 to some power, and so on, where x1, x2 are all the x-intercepts of the graph, where the graph is going to hit the x-axis, and the powers will be determined by what we think the multiplicity is. Remember, if a graph crosses over the x-axis, it'll have an odd multiplicity there. If the graph bounces off the x-axis, it will have an even multiplicity. And we're just going to make it so that it's as simple as possible. And then for the denominator, you have x minus v1 to some power, x minus v2 to some power, and so on. All these v1, v2, all the way up to vm here, these are where the vertical asymptotes are going to occur. And again, the power will depend on what we think the multiplicity of these zeros are for the denominator, where the asymptotes are. Now this time, I mentioned it briefly in the last video that they do talk about the multiplicity of the zeros of the denominator and how you can look at a graph and determine that. I'll just discuss that here. All right. So before I get into this first example, I want to talk about the multiplicities of the zeros of the denominator. If it's an even multiplicity, so like 2, 4, 6, 8, and so on, then the graph's going to be doing this. Here's your v whatever, where your vertical asymptote is. As remember, if something makes the denominator 0, but not the numerator, you're going to have a vertical asymptote. And if that has an even multiplicity, the graph's going to either approach, infinity on both sides or negative infinity on both sides of the asymptote. So basically they'll be going in the same direction. The graph will be going in the same direction on both sides of the asymptote. If it has an odd multiplicity, so 1, 3, 5, 7, etc., then, say here's your vertical asymptote, then the graph is going to be going in opposite directions. Either going down to the left of it and up to the right of it, or up to the left of it and down to the right of it. Okay, so if something makes the denominator 0 but not the numerator, and it has an even multiplicity, the graph will be going in the same direction, either both to infinity or both to negative infinity on either side of that asymptote. And if a number makes the denominator 0 but not the numerator, and it has an odd multiplicity, then the graph's going to be going in opposite directions, on either side of the asymptote. So to negative infinity on one side, positive on the other, or negative and then positive, just opposite directions. All right, so that's something I briefly spoke of in my last video on graphing rational functions. Didn't actually write it out. Here I have. All right. Okay, so what we're going to be doing again is creating the simplest version of a rational function that matches all the information we're given. So every single one of our things is going to look like this. F of x equals, and then again, some scaling factor a, right? Some number a, which we'll find using some other point on the graph, times a fraction, right? Now in the numerator are where your x-intercepts are going to come into play. So you see this function here, they're telling us has x-intercepts at 1, 0, and 5, 0. So the numerator is going to have a factor of x minus 1 and x minus 5. Now notice it didn't say anything about the multiplicities, so we're going to keep those as having a multiplicity of 1. I'm just going to keep the power 1 on both of these. Because it didn't say anything about any multiplicities or how the graph was crossing over or bouncing off the x-axis. So we're going to keep these as simple as possible based on the given information. Alright, so these come into play for the numerator stuff. And then the vertical asymptotes for the denominator. There's a vertical asymptote at x equals negative 4. So that means the denominator has a factor of x plus 4 to some power. And there's a vertical asymptote at x equals negative 1, meaning the denominator has a factor of x plus 1, again to some power. Now, they didn't mention anything about how the graph behaves at these asymptotes. So we don't know if there's even or odd multiplicity, so we're just going to keep it as simple as possible based on the information given and keep those as the first power. Alright, so the vertical asymptotes help you get the factors in the denominator. The x-intercepts will tell you how to get the factors of the numerator. And then the y-intercept, or some other point on the graph, right, we're going to use to find that scale factor. So using the fact that 0, 7's on the graph, that means replace x with 0 and replace f of x with 7. So you have 7 on the left side equals a times, and then 0 minus 1 times 0 minus 5 divided by, and then 0 plus 4 times 0 plus 1 down here. All that's negative 1 times negative 5, that's positive 5. 4 times 1 positive 4, that's 5/4 times a. And then I would multiply both sides by 4/5. And then the value of a would be 28/5. Alright, so I'm going to put the factor, I will put 28 in the numerator, 5 in the denominator. Alright, so putting all this stuff together, we get our function f of x equals 28 times x minus 1 times x minus 5 in the numerator, and then 5 times x plus 4 times x plus 1 in the denominator, right? That's again because a was 28/5, so 28 in the numerator, 5 in the denominator. And here we go. That's all we're asked to do. Now, you want to verify this stuff. Let me go to that Desmos website and punch this function in and see if all this information they told us is happening. So that free online graphing calculator site, desmos.com. And I'll punch in the function I ended up writing, f of x equals, or y equals, 28 times x minus 1 times x minus 5 in the numerator, and then 5 times x plus 4 times x plus 1. And if you want to multiply those out, you can in the denominator. And then look at this, right? You see you got 0, 7 for the y-intercept. You got 1, 0. You got 5, 0 for the x-intercepts. And it has vertical asymptotes at negative 1 and negative 4 well, see, I'll apply x equals -1 and x equals -4. And you can see the asymptotes. I'll make them like dashed or something. In red. But you see how the graph isn't touching those dashed lines, but it is approaching them. All right, they are clearly vertical asymptotes. So there, I have found an equation for a rational function with all the information they gave me. All right, had vertical asymptotes at -4 and -1, x-intercepts at 1, 0, and 5, 0, and a y-intercept at 0, 7. This function here is perfect. And again, if you want to multiply the numerator out, multiply the denominator out, go ahead, but it's the same thing. Okay? All right, so let's do that again. Again, we're just going to be given a graph or just some information and asked to write a function, a rational function that would satisfy all of it. All right, so f of x equals some number a times a fraction. We're told the x-intercepts are -2, 0, and 1, 0, so the numerator is going to have a factor of x plus 2 and another factor of x minus 1. And again, nothing was mentioned about multiplicities here, so I'm just going to keep those to the first power. The vertical asymptotes will determine the denominator factors. X equals -3, so x plus 3 is a denominator factor. X equals 6, so x minus 6 is a denominator factor. Now, here's something nice. This is a degree 2. If you were multiplying this out, this would be degree 2 over degree 2. X squared over x squared. But they told us the horizontal asymptote is is y equals -2, and that's just going to give us the lead coefficient, -2. Because remember, when the degrees are the same, the horizontal asymptote is just the ratio of the lead coefficients, which is what this a is here. So I have everything. So f of x equals -2 times x plus 2 times x minus 1 divided by, and then x plus 3 times x minus 6. And again, you can leave it like this if you wish, or you can multiply everything out, and that's fine too. All right, but this rational function has all the information that they require. All right, has vertical asymptotes at -3 and 6. The x-intercepts would be at -2 and +1, and the graph would approach y equals -2 on both ends. Had that horizontal asymptote. So yeah, there it was even easier. I didn't even need to use a point. Great. And again, you can verify this with a graph, but this time I'll leave that to you. All right, another one. Okay, so vertical asymptote. Now double 0, remember what that means. That means that it's an x-intercept with a multiplicity of 2. Right? So we have f of x equals some scale factor a times a fraction. When they say a double 0 of x equals 1, that means the numerator is going to have a factor of x minus 1 squared. All right, double 0, multiplicity of 2. Vertical asymptote, x equals 3, so you have a factor of x minus 3, or just x minus 3 in the denominator there. And that's it, except for finding a. And this is how now it's not going to be 4, all right, but I use that point. And it's not like the horizontal asymptote thing from last example. So plug in 0 for x, 4 for output, right? 4 for f of x. So 4 equals, it'll be if x is 0, this would be 1 in the numerator, -3 in the denominator, so -1/3 a. And then so a would have to be equal to, multiplying both sides by -3, a would be -12. All right, so there we go. Put it all together. our function's negative 12 times, the quantity x minus 1 squared, all divided by x minus 3, or the quantity x minus 3, whatever. There you go. This function has that vertical asymptote, a double zero at x equals 1, right? There's x minus 1 squared in the numerator. The graph would bounce off the x-axis. In fact, let me actually show this one, because it's a little different. So back on Desmos, I'll put in the function we just wrote. Negative 12 times the quantity x minus 1 squared divided by the quantity x minus 3. Okay, again, zooming out here. Yeah, you can see it. The y-intercept at 0, 4. See how it's bouncing off the x-axis at 1, 0 like a parabola, double zero. And it's got a vertical asymptote at x equals 3. Well, at least it should. It doesn't look very good here, but yeah, okay. It's just because I was zooming so crazy. But you see this blue line. The graph is approaching that blue line, going to infinity on the left side and going to negative infinity on the right side. Because I had x minus 3 to the first, right? In the denominator, x minus 3 to an odd power. So they should be going in opposite. The graph should be going in opposite directions on both sides of the asymptote. And yeah, that's all the information they required. It didn't say anything about horizontal asymptotes or slant. Now this one would have a slant asymptote, right? Because the degree of the numerator is bigger by 1 than the degree of the denominator. But we weren't told about any of that. Okay. All right. Now we're getting into the book problem. I mean, everything I've taken from the book, but now I've just not written it out because I think these are graphs now. The last several problems, I was just given information. Well, here I'm also given information, but it's going to be in graph form. Go to exercise 58 of the text. So at the bottom of the section here, all right, the exercises. So exercise 58. See, we're given. It says use the graphs to write an equation for the given rational function. So here's 58. All right, I'll do this so you can see most. You can see most of the graph here. And I'll write out the information I'm seeing. So vertical asymptotes. Are happening at x equals negative 3 and x equals positive 4. Now do you see at negative 3? See how it's going up to infinity on the left side, but to negative infinity, the graph's going down forever on the right side. So they're going in opposite directions, so this is going to have an odd power on it, odd multiplicity. All right. And the same thing's happening at x equals 4. I know you can barely see it, but it's going to positive infinity on the left side of x equals 4, and the graph's going to negative infinity on the right side. They're going in opposite directions, so it is also going to have an odd power on that factor of x minus 4, odd multiplicity. Now the x-intercepts. Looks like the only x-intercept here is 3, 0. Right, at x equals 3. And you see how the graph crosses straight over? It crosses the x-axis. So again, we're going to have an odd power, an odd multiplicity on that. And this will be x minus 3 in the numerator. And that's it for the x-intercepts. And then one other point on the graph I'm seeing. Now, they don't have any horizontal asymptotes pointed out exactly. So I'm not going to say anything about horizontal asymptotes or slant asymptotes. But another point that I'm clearly seeing is the y-intercept here, which is 0, negative 2. And we'll use that point to find that value of a, that scale factor, like in the previous examples. All right, so now it's just like the other problems I've done. All right. So we have f of x equals, some number a, some scale factor a times a fraction. The numerator is we're getting the zeros, the x-intercepts. So this is x minus 3. All right, I'll put in parentheses to the let's just say the first power. Right, it looked like it crossed straight over, didn't flatten out all that much. So it's gonna have an odd multiplicity, and I'm just gonna keep it as simple as possible. Make it x minus 1, x minus 3 to the first power. And then these vertical asymptotes, those are gonna help me with the factors of the denominator. X equals negative 3, x equals 4. So we have x plus 3 as a factor in the denominator, and x minus 4. And again, both of these are all put to the first power. We saw the graph was going in opposite directions on either side of these asymptotes, so they'll have odd multiplicities, odd powers. And just to keep it as simple as possible, we'll keep it to the first power, both of them. All right, now I just need to find a using the y-intercept, using some other point. So we have negative 2 for f of x equals, and then if x is 0, this would be negative 3, this would be positive 3, so it's negative 1 over negative 4, that's positive 1/4 a. Right? And then the value of a would be negative 8. Right? And then pop that in. So we have f of x equals negative 8 times the quantity x minus 3 all over, x plus 3 times x minus 4. And there you go. Right, there's a rational function. And if you want to, again, if you want to multiply these out, you can have that be negative 8x plus 24 in the numerator. And then multiplying these two in the denominator, we get x squared minus x minus 12. This is the same thing. And I'll enter that, and we're going to see the same graph. Right? We're going to see that graph is the exact same as this one here. Right? So I'm going to go to the Desmos site. We'll check it out. F of x equals, I'll put in that multiplied version when I multiplied it out, negative 8x plus 24. You can put in the factored form too, it doesn't matter, right? As long as you enter it properly. X squared minus x minus 12. And look at this, right, compared to this. Looks pretty close, looks pretty similar. And it's got the same asymptotes, got the same intercepts, right? You got 3, 0 crossing over, you got 0, negative 2, going to infinity to the left of negative 3, going to negative infinity to the right of negative 3, going to positive infinity to the left of x equals 4, going to negative infinity to the right of x equals 4. Looks pretty darn close to this. Alright, so I think my function is pretty good. Right, and I'll stick with it. Alright. Great. Alright, so moving on. I'm going to do a few more of these with the graphs. We have exercise 60, the next even numbered one from the text. Alright, so there's 58 and 60, same thing, pretty similar. I'm just going to write out the information. You don't have to see what I'm writing. I'll just say it, and you'll see it after I'm done. So I'm going to say, hey, the vertical asymptotes, I'm clearly seeing those. The vertical asymptotes are at x equals negative 3 and x equals 4. And you see at x equals negative 3, the graph is going in opposite directions on either side. So that's going to have an odd power on its factor, on the factor of x plus 3 in the denominator. And x equals 4, you see how the graph is going in the same direction? See, it's going to negative infinity on both sides. So that's going to have an even power on it. And I'll just make it 2, the second power, to make it as simple as possible. All right. And then for the x-intercepts, right, so I know what the factors in the numerator are. It looks like there's only the one x-intercept at 2, right, 2, 0, x equals 2. And it crosses over, right? The graph doesn't bounce off the x-axis, it crosses the x-axis. So that's going to have an odd power on it, an odd multiplicity. And the point 0, 1 is on it, right? I need some other point to find that scale factor, right? To find the value of that a. And the point, 0, 1 is clearly on this graph. Alright, so just like all the other problems now. So here's all the information I've written out from that picture. And just like the other problems now, f of x equals, a times some fraction. X-intercepts help you with the numerator. 2, 0 is x equals 2 is an x-intercept. So the quantity, x minus 2 is a factor up here, and it crossed over. So it's going to have an odd power. So I'm just going to leave that to the first. Make it as simple as possible. Denominator comes from the vertical asymptotes. X equals negative 3, right, was a vertical asymptote. So x plus 3 is a factor of the denominator. Again, the graph was going in opposite directions on either side of that asymptote, so it's going to have an odd power, so I'm just going to leave that to the first. But x equals 4, right, the graph was going in the same direction on either side, so it's going to have an even power, so I'm going to have x minus 4, and then I'll just put the second power there, just again, keep it as low as possible. It could be 2 or 4 or 6, but just to keep things as low as possible, I'm going to make that x minus 4 squared. And now we just need to find a, right, and that's where this comes in. The point 0, 1 is on this graph, 1 for f of x, and then I replace x with 0. So this would be negative 2 over, and then you got times a. Negative 2 over 3 times 16, so 48. So that's negative 1/24 times a, so the value of a is negative 24. And I'm popping that in, right? So f of x, y equals negative 24 times x minus 2 divided by x plus 3 times x minus 4 squared. And again, you can multiply this stuff out if you wish, or just type use this. This is fine too. And I'm going to type this in. I'm going to enter this into that Desmos website or some graphing calculator and compare it to the graph what we were given here. All right, this graph here. Alright, so the function I ended up with was f of x equals negative 24 times the quantity x minus 2 divided by then the quantity x plus 3 times x minus 4 squared. And I'll zoom this out a bit. You can see 0, 1, you can see 2, 0, right, crossing over. It's going to and then look at this, how this compares. It looks pretty much the same. Looks pretty good. See, it's going to negative infinity to the left of negative 3, positive infinity to the right of negative 3. That's happening here. It's going to the graph's going down forever to negative infinity on both sides of x equals 4. That's happening here. It's got 2, 0, 0, 1. It's crossing over the x-axis at 2, 0. Looking exactly like this. Exactly. So again, looks like I did a pretty decent job there finding a function to fit this graph. Okay. Then the next one is just going to be, the very next, just 62, and then I have 64 after this. So just more exercises from the back of the end of the section here. So 62. Okay. Aha. So it looks like, again, I'll just write out the information. Got a vertical asymptote at x equals negative 2, right? And if you notice, on either side, the graph is going in the opposite directions on either side of this. A negative infinity on the left, positive infinity on the right. So I'm going to have an odd power on the factor of x plus 2 in the denominator. X-intercepts, it's got 1 and negative 4, and it's crossing over at both of them. So it's going to have I'm going to have odd powers on those as well. All right. X equals negative 4, x equals positive 1, both odd. Right? Both odd multiplicities. The graph is crossing over the x-axis here. It's not bouncing off the x-axis. And it looks like it has a slant asymptote, not a horizontal one. Remember, a slant asymptote tells me that the degree of the numerator should be 1 more than the degree of the denominator, or at least bigger than the degree of the denominator. So just keep that in mind. All right. When I'm done with this, the degree of the numerator should be bigger by 1 than the degree of the denominator. And it looks like I got the point 0, 1. Right, 0, 1 is on the graph. Another point on the graph, the y-intercept. All right, so I've got all that information written out. Now it becomes just like all the other problems. Right. So we have f of x equals a times, right, some scale factor a. Now the numerator comes from the x-intercepts. Right? We had x plus 4, since x equals negative 4 is a 0, and times x minus 1. And again, both of these I'll keep to the first power, right? Odd multiplicities. And the denominator comes from the vertical asymptote, so we have x equals negative 2, so x plus 2 is the factor down there. And once again, the graph was going in opposite directions on either side of that asymptote, so it should have an odd power. So I'll again keep it. And I'm going to keep that as 1. Because look, there are 2 factors in the numerator, that makes it an x, that's a degree 2 polynomial. And if I leave the 1 factor down here as a degree 1, so it should have that slant asymptote, right? You have a degree 2 divided by a degree 1. And that graph looked like it had a slant asymptote to me. So I'll leave those, and then now we just need to find a coming from the point 0, 1. So 1 for f of x. And if x were 0, you'd have negative 4 divided by 2, negative 2a. So a is negative 1/2. So negative 1 in the numerator, 2 in the denominator. All right. So putting that in, we have f of x equals, negative 1 times the quantity x plus 4 times the quantity x minus 1 divided by, and then 2 times the quantity x plus 2. Right? Again, negative 1 in the numerator, 2 in the denominator when you replace a with negative 1/2. And there we go. And once again, if you want to multiply all that out, go ahead. But let me just let me double check. I'm going to put this into my graphing calculator at Desmos, and we'll compare it to the graph we were given in the assignment. All right, so back here. So the function I ended up writing was f of x equals negative 1 times the quantity x plus 4 times x minus 1 divided by, and then 2 times the quantity x plus 2. And yeah, that looks pretty close to what I'm looking at here. So going to negative infinity to the left of negative 2, positive infinity to the right of negative 2, you got 0, 1, you got 1, 0, you got negative 4, 0. The graph's crossing over at those. Looks like it has a nice slant asymptote with a line going from upper left to lower right. Looks pretty darn close to me. So good function. All right, I got just one more of these. It's just the very next one. Right, exercise 64 from the text. All right, so again, I'll write out the stuff while I'm saying it, and we'll come back. We'll go to my paper and work it out. All right, so the vertical asymptotes, VAs, x equals negative 2 and x equals 4. All right, you see x equals negative 2, a vertical asymptote, x equals 4. X equals negative 2, the graph is going in opposite directions. All right, graph is going in opposite directions, so it should have an odd power on that factor. And again, I'll probably just keep it as 1 to the power of 1. And then x equals 4. See how the graph is going in the same direction on both sides, going to positive infinity on both sides. So that'll have an even power on it, which I'll probably just make 2, right, to keep things as small as possible. All right, now the x-intercept looks like x equals 2 here on the x-axis, but it's bouncing off. All right, x equals 2, 2, 0. But the graph is, see how it's bouncing off? It's coming in and then touching the x-axis and bouncing off. So that's going to happen when you have an even multiplicity. Right. And that looks like it for the x-intercepts. And then, what's another point that's clearly on this? Because the y-intercept isn't very obvious here. Yeah, there isn't anything very obvious that's on this graph. Now, it looks like it might be. I can't really zoom in. I guess I could. Oh, that was a search. Okay. Yeah, zooming in, zooming back out. Oops, sorry. Things got bounced around on me. I guess if we had to pick another point here, I would say maybe negative 1, 1 is on the graph as well. Because, yeah, I'm not really seeing anything else that's obviously on the graph. Yeah, so I'll pick negative 1, 1 because it looks like the horizontal asymptote is the x-axis, y equals 0, and all that means is that the denominator is going to have a higher degree than the numerator. Right. So I'll use the point negative 1, 1 just because it looks close. Alright, so back to my paper. Sorry about all that struggle with my mouse there. Same setup, f of x equals some number a, some scale factor a times a fraction. X equals 2, but with an even multiplicity, right? So x minus 2 to the second power. Right. And then the denominator factors come from the vertical asymptotes, VAs. X equals negative 2, so x plus 2 is a factor. To an odd power, right? The graph was going in opposite directions on either side of that one. So I'll just leave it to the first power. And then x equals 4 is a vertical asymptote, right? So x minus 4 should be a factor of the denominator. But the graph was going in the same direction on both sides, so it should be to an even power. I have an even multiplicity, so I'll put the square on that. And that way, the denominator has a higher degree than the numerator, and the horizontal asymptote should be the x-axis the way it was looking. Okay. So yeah, like I said, I guess the only point that looks kind of like it was totally easy to see on the graph was negative 1, 1. Right, so I'll use that. So 1 for the output equals a times, and then if x is negative 1, negative 1 minus 2 is negative 3 squared is 9. Negative 1 plus 2 is 1. Negative 1 minus 4 is negative 5. Squared is 25. Right, so a would be 25 ninths. Right, 25 ninths. So putting that in, that'll just put 25 in the numerator, 9 in the denominator. So we have f of x equals 25 times x minus 2 squared divided by 9 times the quantity x plus 2 times x minus 4 squared. And once again, just to double check my work, I'm going to punch this into my Desmos calculator and see how it compares to the graph we were given. So f of x equals 25 times the quantity x minus 2 squared divided by 9 times x plus 2 times x minus 4 squared. Alright, and then let's look at that compared to this, and it looks pretty good. Yeah, that looks pretty good to me. Yeah. Again, it's rough because I use negative 1, 1, even though negative 1, 1 isn't obvious here. But it looks like everything's working out, right? Going to the negative infinity to the left of negative 2, positive infinity to the right of negative 2. That is happening here. Going to positive infinity on both sides of 4. You got 2, 0 where it's bouncing off the x-axis. The x-axis is a horizontal asymptote, right? All that stuff is happening in this graph here. So looks like my function's pretty good, right, in my opinion. Okay, so that's it. All right, that's all I got. Just doing pretty much the same thing every time, right? I made sure to know what the vertical asymptotes were, the x-intercepts were, to give me the factors that'll be in the numerator and denominator. Talk about the multiplicities of those factors. How many should they have odd powers, even powers? And then either knowing what the horizontal asymptote is or knowing what another point on the graph is, I could find that scale factor a and then complete the function. All right. And I'm hoping that watching me go through these 7 examples here help you in some way when you're trying to write an equation for a rational function on your own. And thank you very much for watching.